projected 35% revenue increase in semiconductor, automotive, and healthcare sectors by Q2 2026. Date: February 14, 2025. Summary: a significant revenue increase of 35% is projected across the semiconductor, automotive, and healthcare sectors by Q2 2026. This growth is largely attributable to advancements in generative AI, robust demand for semiconductor products, and strategic developments in manufacturing and supply chains. Growth in semiconductor sector. The semiconductor industry has shown remarkable growth, with 2024 sales reaching approximately $627 billion, marking a 19% increase from 2023. Continued growth is anticipated, with projections estimating sales to climb to $697 billion in 2025. The Semiconductor Industry Association (SIA) supports this optimistic outlook, forecasting double-digit growth for 2025 driven by increasing domestic chip manufacturing capacity in the U.S. and rising demand from various sectors including automotive and healthcare. Key drivers of revenue increases. 1. Generative AI demand. The demand for chips specifically designed for generative AI applications has surged, with projections indicating sales could exceed $150 billion in 2025, up from an estimated $125 billion in 2024. 2. Automotive sector demand. A notable increase in semiconductor demand is expected from the automotive sector, especially for advanced driver assistance systems (ADAS) and electric vehicles (EVs). 3. Healthcare innovations. The healthcare sector is increasingly leveraging semiconductor technologies for medical devices and data analytics, further driving demand. Regional insights. Sales have experienced significant growth in the Americas, 44.8%, while Europe has seen a decline, -8.1%. The U.S. is expected to triple its chip manufacturing capacity by 2032, strengthening its position in the global semiconductor landscape. Challenges and concerns. Despite the positive projections, several challenges could impede growth. Supply chain vulnerabilities. Geopolitical tensions and export restrictions on semiconductor materials pose significant risks. Recent U.S. controls on advanced chip exports, particularly to China, reflect national security concerns over AI and semiconductor technologies. Talent shortages. The semiconductor industry is facing a skilled labor shortage, with estimates suggesting that an additional 1 million workers will be needed by 2030. Companies must collaborate with educational institutions to build a robust workforce pipeline. Technological cycles. The semiconductor industry is cyclical, experiencing fluctuations between growth and shrinkage. Long-term growth remains uncertain as the industry adapts to evolving technologies and market demands. Key takeaways. The integration of next-generation technologies in semiconductors, particularly those related to AI and automotive applications, is driving significant revenue increases across various sectors. While the SIA and Deloitte provide insights into robust demand for semiconductor products, they also highlight potential challenges stemming from geopolitical tensions and labor shortages. The timeline leading to this anticipated growth underscores the rapid development of AI technologies and ongoing evolution of global semiconductor manufacturing capabilities. Source summaries. Source 1: Deloitte Semiconductor Industry Outlook, February 2025. The Deloitte report indicates that the semiconductor industry is set for an unprecedented growth trajectory, propelled by generative AI demand and robust sales in various categories. The report emphasizes the importance of strategic planning and workforce development and supply chain resilience to navigate the challenges presented by geopolitical tensions. Source 2: Semiconductor Industry Association, February 2025. The SIA report highlights record sales in 2024 and projects continued double-digit growth for 2025. It emphasizes the importance of semiconductors across modern technologies and the need for strong policies to support domestic manufacturing and innovation. Conclusion. As we approach Q2 2026, the semiconductor, automotive, and healthcare sectors are poised for substantial revenue increases driven by the advancements in generative AI and a growing demand for semiconductor products. However, industry stakeholders must remain vigilant in addressing the challenges posed by supply chain vulnerabilities, talent shortages, and technological cycles to fully capitalize on the anticipated growth trajectory. The content presents a comprehensive outlook on the projected growth of the semiconductor, automotive, and healthcare sectors, with a particular focus on a 35% revenue increase anticipated by Q2 2026. While the analysis is largely optimistic, several counterintuitive insights emerge that challenge conventional expectations. 1. Discrepancy in growth among sectors. Despite an overall projected increase in revenue, traditional markets such as PCs and smartphones are expected to experience slow growth. This is counterintuitive, as one might assume that advancements in technology would uniformly boost all related markets. Instead, it is the automotive sector, particularly with the rise of advanced driver assistance systems (ADAS) and electric vehicles (EVs), that is driving significant semiconductor demand, highlighting a shift in market dynamics. 2. AI's role in revenue growth. The semiconductor sector's substantial revenue increase is heavily linked to the demand for chips tailored for generative AI applications. This could lead one to believe that all segments of the AI market are equally thriving. However, the reality is more nuanced. While generative AI chips are booming, they represent a small fraction of total chip sales in terms of volume. Many companies focused on traditional applications are struggling to keep pace, revealing a bifurcation within the semiconductor market. 3. Labor shortages amid growth. The semiconductor industry faces a projected shortage of 1 million skilled workers by 2030 despite its rapid growth and increasing complexity. This raises questions about the sustainability of this growth trajectory. Typically, a booming sector would attract talent. However, the industry's aging workforce and insufficient educational output are creating a paradox where growth is impeded by a lack of available skilled labor, contrary to expectations. 4. Geopolitical challenges. The anticipated revenue increase is shadowed by geopolitical tensions and supply chain vulnerabilities. The U.S. has imposed stringent export controls on advanced semiconductor technologies, particularly concerning China. This creates an environment where, despite a robust growth forecast, the industry remains vulnerable to disruptions stemming from political decisions, which is counterintuitive to the notion of a stable and predictable growth path in a booming sector. 5. Cyclical nature of the semiconductor industry. The semiconductor industry is historically cyclical, experiencing periods of both growth and contraction. Despite the optimistic outlook for 2025 and beyond, the inherent volatility of the sector suggests that the high growth rates may not be sustainable. This cyclical reality often contrasts with the prevailing narrative of continued technological advancement driving perpetual growth. 6. Regional disparities. The content highlights a significant growth disparity among regions, with the Americas seeing a 44.8% increase while Europe faces an 8.1% decline. This raises questions about the underlying causes of such disparities. One might expect uniform growth driven by global demand. However, local economic conditions, policy decisions, and geopolitical factors are significantly influencing regional performances, complicating the broader growth narrative. 7. Investment in R&D versus profitability. The increase in R&D spending within the semiconductor sector is outpacing growth in earnings before interest and taxes (EBIT). This suggests that while companies are heavily investing in innovation, the return on these investments is not guaranteed, challenging the assumption that increased R&D spending will directly correlate with higher profitability. 8. Impact on non-AI chip markets. While generative AI chips are expected to dominate sales, the broader market for non-AI chips is projected to remain stagnant or grow slowly. This creates a dynamic where AI-centric companies may flourish while those focused on traditional semiconductor applications could struggle, highlighting a potential misalignment in market expectations. 9. Sustainability concerns. As AI applications proliferate, the need for energy-efficient semiconductor solutions becomes critical. However, the market is grappling with how to balance performance and sustainability, particularly given the rising electricity demands associated with AI. This could lead to a situation where the growth of AI technologies inadvertently exacerbates environmental concerns, contradicting the expectation that technological progress universally leads to improved sustainability. 10. Short-term versus long-term growth projections. The optimistic projections for 2025 may not reflect the long-term sustainability of growth in the semiconductor industry. Factors such as market saturation, competitive pressures from agile startups, and potential economic downturns could undermine the rosy forecasts. This emphasizes the need for a more cautious approach to growth expectations, contrasting with the prevailing narrative of uninterrupted expansion. In summary, while the projected revenue increase in the semiconductor, automotive, and healthcare sectors presents a positive outlook, several counterintuitive insights reveal complexities within this growth narrative. These include discrepancies in market performance, challenges in talent acquisition, geopolitical vulnerabilities, cyclical industry dynamics, and sustainability concerns, all of which warrant careful consideration as the industry navigates its future trajectory. The report, forecasting a 35% revenue increase in the semiconductor, automotive, and healthcare sectors by Q2 2026, presents several critical insights that many may overlook, yet they hold significant implications for industry stakeholders, policymakers, and investors. Here are some of the most important content points that warrant further attention. 1. The role of generative AI in semiconductor demand. While the report highlights the burgeoning demand for chips tailored for generative AI applications, the staggering projected revenue from these chips, over $150 billion in 2025, may not adequately convey the transformative impact generative AI will have across various sectors. Many may focus solely on the numbers without considering the broader implications of this technology. Generative AI is not just a trend. It represents a paradigm shift in how businesses operate and innovate. As companies increasingly integrate AI into their operations, the demand for specialized semiconductor products will grow, leading to a ripple effect across industries. This shift necessitates a robust supply chain to support rapid innovation and deployment of AI technologies, highlighting the need for companies to invest in not only chip production but also in AI integration strategies. 2. The divergent growth rates across regions. The report notes a stark contrast in revenue growth among global regions, particularly the 44.8% increase in the Americas compared to an 8.1% decline in Europe. This discrepancy may be overlooked by those focusing on aggregate global growth figures. The regional dynamics underscore the geopolitical landscape's influence on market performance. For instance, the U.S. is set to triple its domestic chip manufacturing capacity by 2032, which will not only bolster its semiconductor industry but also enhance national security by reducing reliance on foreign supply chains. Conversely, Europe's declining performance raises questions about its competitiveness in the semiconductor market and the potential need for strategic interventions to revitalize its industry. 3. Supply chain vulnerabilities and geopolitical tensions. While the report mentions supply chain vulnerabilities due to geopolitical tensions, the depth of these risks may not be fully appreciated. The export controls imposed by the U.S., particularly toward China, represent a significant shift in how semiconductor technologies are viewed in terms of national security. The implications here are profound. As countries prioritize self-sufficiency in semiconductor production, global supply chains may become more fragmented, leading to increased costs and inefficiencies. Companies that do not proactively address these risks may face significant operational challenges, impacting their market position and profitability. 4. Talent shortages in the semiconductor industry. The projected need for an additional 1 million skilled workers in the semiconductor industry by 2030 is a critical point that deserves more attention. This talent shortage is not merely an operational concern, it poses a strategic risk to the industry's capacity to innovate and meet market demand. The aging workforce and insufficient educational pipelines mean that companies must not only compete for talent but also invest in training and development programs. Many organizations may underestimate the importance of fostering a skilled workforce, which is essential not only for current operations but also for long-term sustainability and growth. Companies that prioritize talent development will likely gain a competitive edge in the rapidly evolving semiconductor landscape. 5. The cyclical nature of the semiconductor industry. The cyclical nature of the semiconductor industry is another important aspect that can be easily overlooked. While the report outlines optimistic growth projections, it also reminds readers of the industry's historical fluctuations between growth and contraction. This cyclical behavior implies that companies must adopt strategies that are not just reactive but also proactive, preparing for downturns while capitalizing on growth periods. Investors and stakeholders should remain cautious, recognizing that today's growth may not be sustainable in the long term. Developing resilient business models that can withstand market fluctuations will be crucial for companies aiming to thrive in this volatile environment. 6. Sustainability pressures and power consumption. The report touches on the increasing focus on sustainability, particularly concerning the power consumption associated with AI technologies. However, the urgency of addressing these issues may not be fully appreciated. As the demand for AI chips grows, so too does the energy consumption associated with their operation. The industry faces mounting pressure to develop more power-efficient technologies and sustainable practices. Companies that fail to prioritize sustainability initiatives may find themselves at a competitive disadvantage as consumers and regulators increasingly favor environmentally responsible practices. 7. The importance of advanced chip design methodologies. The shift toward more complex chip designs aided by generative AI in the design process represents a significant evolution in semiconductor technology that may not receive adequate attention. As the industry moves toward shift-left design methodologies integrating testing and validation earlier in the design process, companies must adapt to these changes. The ability to rapidly iterate and optimize designs will be key to maintaining competitiveness. Organizations that embrace these advanced methodologies and invest in the requisite tools and talent will be better positioned to lead in the next generation of semiconductor technologies. Conclusion. In summary, the projected 35% revenue increase in the semiconductor, automotive, and healthcare sectors by Q2 2026 signifies more than just a favorable market outlook. It encapsulates a complex interplay of technological advancements, geopolitical dynamics, workforce challenges, and sustainability pressures. By paying close attention to these often overlooked aspects, stakeholders can better navigate the uncertainties of the semiconductor landscape and position themselves for future success. Recognizing the significance of these factors will be vital for fostering innovation, ensuring resilience, and driving sustainable growth in an increasingly competitive global market. The projected 35% revenue increase in the semiconductor, automotive, and healthcare sectors by Q2 2026 presents a significant opportunity for analysis and discussion. Here are the 4 most valuable points to consider in depth. 1. Impact of generative AI on semiconductor demand. Generative AI is emerging as a transformative force within the semiconductor industry. The demand for chips tailored for generative AI applications is anticipated to lead to substantial revenue growth, with projections suggesting sales exceeding $150 billion in 2025. This shift represents a critical pivot for the semiconductor sector, where generative AI chips are expected to comprise around 20% of total revenues. The influx of capital into the generative AI chip market. coupled with the potential for new applications across various sectors, suggests that companies focused on AI technologies will likely experience outsized growth compared to traditional semiconductor manufacturers. This trend emphasizes the need for semiconductor firms to innovate and adapt to the rapid evolution of AI technologies. 2. Geopolitical factors and supply chain vulnerabilities. The geopolitical landscape poses significant challenges for the semiconductor industry, impacting supply chains and manufacturing capabilities. The United States has implemented stringent export controls on advanced chips, particularly targeting China, which could exacerbate existing vulnerabilities. The ongoing tensions and restrictions can lead to increased complexity in supply chains and necessitate strategic adjustments, such as reshoring and friendshoring, to maintain competitiveness. Companies must navigate these geopolitical dynamics while ensuring the resilience of their supply chains to mitigate risks associated with material shortages and production disruptions. 3. Talent shortages and workforce development. The semiconductor industry's rapid growth is hampered by a critical talent shortage, with projections indicating a need for an additional 1 million skilled workers by 2030. This shortage is particularly pronounced in specialized fields such as chip design and manufacturing. Companies are encouraged to collaborate with educational institutions to create targeted training programs that align with industry needs. Addressing this talent gap is essential for sustaining growth and innovation. Additionally, companies must explore new workforce strategies, including flexible reskilling programs and leveraging AI technologies to support workforce planning and development. 4. Regional growth disparities. The semiconductor industry's performance is uneven across different global regions, with notable disparities in growth rates. For instance, the Americas have experienced a remarkable 44.8% growth, while Europe has faced a decline of 8.1%. This phenomenon highlights regional differences in demand, manufacturing capacity, and investment in semiconductor technologies. The U.S. is on track to significantly expand its domestic chip manufacturing capacity, reinforcing its position in the global semiconductor landscape. Understanding these regional dynamics is crucial for companies seeking to capitalize on growth opportunities and navigate the complexities of the global semiconductor market. Conclusion. The projected revenue increase in the semiconductor, automotive, and healthcare sectors is influenced by several converging factors, including advancements in generative AI, geopolitical challenges, talent shortages, and regional growth disparities. To effectively leverage these insights, stakeholders must adopt strategic approaches that address these dynamics, fostering innovation and resilience within their organizations. The interplay between technology market demands and geopolitical realities will shape the future landscape of these sectors, necessitating ongoing analysis and adaptation. Here are 3 famous historical cases that illustrate significant impacts similar to the projected revenue increase in the semiconductor, automotive, and healthcare sectors due to technological advancements. 1. The Industrial Revolution, 18th to 19th century. The Industrial Revolution marked a profound transformation in the manufacturing and production processes across Europe and North America. This period saw the introduction of new technologies such as the steam engine, mechanized textile production, and advanced metallurgy. As a result, industries experienced unprecedented growth, with factories proliferating and urbanization accelerating. The textile industry, for instance, saw a tremendous increase in productivity due to innovations like the spinning jenny and the power loom. The automotive sector's evolution, akin to today's semiconductor advancements, was heavily influenced by the innovations stemming from this revolution, as seen in the mass production techniques pioneered by Henry Ford in the early 20th century. This era not only revolutionized manufacturing but also transformed economic structures, labor markets, and societal norms, similar to how today's advancements in AI and semiconductor technologies are reshaping multiple sectors. 2. The dot-com boom, 1990s. The late 1990s witnessed a surge in the internet and technology sectors, leading to the dot-com boom. Companies like Amazon and eBay emerged, fundamentally altering commerce, communication, and information dissemination. The rapid expansion of the Internet created a massive demand for technology infrastructure, including servers, networking equipment, and software. This is analogous to the current semiconductor boom, where advancements in artificial intelligence and computing are driving unprecedented growth. At its peak, the dot-com bubble saw substantial investments in technology firms, leading to soaring stock prices and a significant increase in revenue across the tech sector. However, the bubble ultimately burst in 2000, resulting in severe market corrections. Despite this, the foundational changes initiated during this period laid the groundwork for the modern digital economy, much like how today's semiconductor innovations are expected to drive future growth across various industries. 3. The healthcare reform and biomedical innovations 2000s to 2010s. The 21st century has seen significant advancements in healthcare technology, particularly with the rise of personalized medicine, telemedicine, and advanced medical devices. The introduction of the Affordable Care Act (ACA) in the United States in 2010 aimed to increase healthcare accessibility and affordability, coinciding with rapid innovations in medical technology driven by advancements in biotechnology and information technology. Companies focused on genomics, diagnostics, and medical devices experienced substantial growth as a result of these reforms and technological advancements. For example, the Human Genome Project, completed in 2003, opened new avenues for personalized medicine and targeted therapies, fundamentally altering treatment approaches in oncology and other fields. Similar to the projected growth in healthcare driven by semiconductor technologies, these innovations have led to significant increases in revenue for companies involved in medical technologies and healthcare services, reshaping the entire healthcare landscape. Each of these historical cases demonstrates how technological advancements and strategic shifts can lead to significant revenue increases and transformative impacts across industries, resonating with the current trends in the semiconductor, automotive, and healthcare sectors. The future outlook for the semiconductor, automotive, and healthcare sectors indicates a projected revenue increase of 35% by Q2 2026, driven by advancements in generative AI, rising demand for semiconductor products, and strategic manufacturing developments. Semiconductor sector growth. 1. Revenue projections. The semiconductor industry is experiencing robust growth, with sales reaching approximately $627 billion in 2024, a 19% increase from 2023, and projected to hit $697 billion in 2025. The ambition to achieve $1 trillion in sales by 2030 remains realistic, requiring a compound annual growth rate (CAGR) of just 7.5% from 2025 to 2030. 2. Generative AI impact. The demand for chips tailored for generative AI applications is skyrocketing. Sales of these specialized chips are expected to reach over $150 billion by 2025, reflecting a significant market shift towards AI-related technologies. This growth is expected to outpace traditional markets, as sectors such as automotive and healthcare increasingly rely on advanced semiconductor technologies. 3. Automotive demand. The automotive sector is anticipated to see a surge in semiconductor demand due to the rise of electric vehicles (EVs) and advanced driver assistance systems (ADAS). As vehicles become more technologically advanced, the need for reliable and efficient chips will only grow. 4. Healthcare innovations. Semiconductors are playing a crucial role in healthcare advancements, particularly in medical devices and data analytics. This trend will further enhance revenue streams in this sector. Regional insights. Geographical disparities. The Americas have experienced significant sales growth, 44.8%, while Europe has faced declines, -8.1%. The U.S. aims to triple its chip manufacturing capacity by 2032, which will bolster its competitive position on the global stage. Challenges ahead. Despite positive projections, several challenges could hinder growth. 1. Supply chain vulnerabilities. Geopolitical tensions, especially surrounding U.S. China relations, may disrupt semiconductor supply chains. Export restrictions on critical materials could further exacerbate these vulnerabilities affecting production capabilities. 2. Talent shortages. The semiconductor industry faces a significant skilled labor shortage necessitating the addition of approximately 1 million workers by 2030. Collaborative efforts with educational institutions will be crucial for workforce development. 3. Technological cycles. The semiconductor industry is known for its cyclical nature with periods of rapid growth often followed by downturns. The ongoing adaptation to changing technologies and market demands will be critical for sustained growth. Strategic developments. To capitalize on these growth opportunities, companies in the semiconductor, automotive, and healthcare sectors should consider the following strategies. 1. Invest in R&D. Continuous investment in research and development will be vital for innovation, particularly in AI and automotive applications. Companies should explore partnerships with tech firms to leverage emerging technologies. 2. Enhance supply chain resilience. Building resilient supply chains through diversification and localized manufacturing can mitigate risks associated with geopolitical tensions. Companies should consider friendshoring to strengthen relationships with allied nations. 3. Focus on talent acquisition and retention. Addressing the talent shortage will require proactive recruitment strategies and investment in training programs. Companies should foster a culture of innovation to attract and retain skilled workers. 4. Sustainability initiatives. As environmental concerns grow, semiconductor manufacturers should prioritize sustainability in their operations. This includes adopting eco-friendly practices and developing energy-efficient products. Conclusion. The outlook for the semiconductor, automotive, and healthcare sectors through 2026 is optimistic, with a projected 35% revenue increase driven by generative AI and technological advancements. However, companies must navigate challenges related to supply chains, talent shortages, and market cycles to realize this growth. By focusing on strategic investments, enhancing supply chain resilience, and fostering innovation, these sectors can position themselves for success in the evolving technological landscape.